Point a finger into the night sky. Draw a line from the tip of your finger out into space, as far out as it will go. The observable universe has around 1 billion trillion stars, so you may expect this line to bump into matter sooner or later. But unless you are very lucky, you will almost certainly be able to have an unbroken line between you and the edge of our observable universe. The universe just ain't that dense. Space is named very well. If you could follow that line all the way out to the edge of the universe, what would you find? And what does it mean for our universe to even have an edge? We will follow 3 different rockets, 2 impossible, 1 realistic, on their journeys to the edges of the universe. Welcome to my channel. If chill space videos are your thing, please subscribe, comment too. First of all, we have an impossibly powerful rocket, one that allows us to travel far beyond the speed of light, ignoring the strange effects of Einstein's general relativity. A journey across our galaxy takes 100,000 years for light. For this rocket, it can travel that distance in the blink of an eye. You maneuver the ship to head in the direction you pointed. There is a maximum distance we can see from Earth. This is determined by the speed of light. However, the universe extends beyond this point. It is just invisible to us, as light hasn't had time to reach us. Our observable universe is about 46 billion light years in radius, and this is the distance we will cover. You fire up the warp drive, and we flash by galaxy after galaxy. 3, 2, 1. As the warp drive powers down, you notice the universe looks normal. Different, but normal for sure. Looking out your window, you see a galaxy below you, a spiral galaxy, not dissimilar from the Milky Way. Your sensors show that this neighbourhood of the universe is basically the same as ours. It doesn't matter if you point your finger out into the universe again and travel there. Again and again. Wherever you go, the universe looks pretty much the same. Sure, the galaxies are slightly different in their precise form and shape, like snowflakes, and they are in slightly different arrangements. But nothing is fundamentally different. We don't know if you could keep discovering new space if you kept going infinitely. Possibly, the universe wraps around itself, which would mean you would come back to where you started. But no matter how far you go, you never reach an edge, a part where space just stops. The universe we can see from Earth is not the entire universe. We can only see the observable universe, a bubble in which light has had time to reach us. Quite possibly, the universe extends out forever, but at the very least, it is significantly larger than the observable universe. Our magic spaceship ignored the speed limit of reality, letting us explore way beyond our observable universe. But at every point of space we stop, we are at the centre of a unique bubble of observable universe. You notice that wherever this spaceship stops, your sensors detect a trace of radiation from all directions. This radiation emanates from the edge of the observable universe, the leftover radiation from the Big Bang. Our next journey will take us to its origin, back in time. Our second rocket goes back in time as it travels. Every light year in distance it travels, we travel back in time by a year. A trip to our nearest star from the Sun would take us back in time 4 years, as it is roughly 4 light years away. We point the spaceship to a random patch of the sky. We will follow back the journeys of light coming from the edge of the universe to the start of their journey. This cold radiation hits Earth from every direction in space. It comes from beyond the furthest galaxies, from every point in the sky. Because the speed of light is finite, and the universe's age is finite, there is a limit to what we can see, and this radiation marks the limit, like a veil we can't see beyond. Images of this radiation look like this. I'd recommend checking out my 360 video on this radiation, which shows how it surrounds us. At the beginning of our journey, the universe looks pretty normal. As the chronometer shows we are travelling billions of years into the past, we notice that all galaxies are getting closer and closer together. It looks like if we continue on long enough, the galaxies will be on top of each other. But before this can happen, the galaxies appear to disintegrate into gas. When we close in on our destination, our sensors show plasma has surrounded us. The whole universe is bright and hot like the surface of our Sun. We have travelled through space 13.7 billion light years from where we have started, and we have rewound the clock the same number of years. If we continued on our journey for another 400,000 years, we would be at the very beginning of the universe, at time 0. This plasma, glowing hot from the residual heat of the Big Bang, would melt our ship if it weren't for our impossible shield. But as we wait, time moving in the correct direction now. The universe expands, and as it expands, the plasma around us cools. It stops glowing. It becomes a transparent gas. Photons, packets of light, had been bouncing around in the plasma, unable to travel very far. But as the plasma turned into gas, suddenly this light was released out into the rest of the universe. The universe is infinite, but the light moves at a finite speed. The whole universe went from plasma to gas at the same time, but as light takes time to travel, we continue to see the residual heat from more and more distant places in the universe, and it marks the furthest we can see. The continued expansion of the universe causes the radiation to lose energy, which is why today we see it as a wisp. This gas will become the stars and galaxies of our current universe. Gravity gradients from tiny fluctuations in the density of the gas, caused by sound waves echoing through it, will go on to form the cores of galaxies. Today we continue to pick up this same radiation, although it has been diluted to a temperature just above absolute zero. The universe was opaque at this time. Plasma causes light to bounce around and get trapped. If scientists want to probe beyond this point, light will not help us. The only way to see beyond is with telescopes that detect gravitational waves or neutrinos. We could continue on our journey, turn the engines on again, to the very start of the universe. The universe would get hotter and hotter, but known science breaks down as we approach the very beginning of our universe, so it's difficult to talk with any certainty about what would happen. The very start of our universe, at the Big Bang, seems about as true an edge of the universe as we can hope for. The final rocket we will use is the most realistic. It is constrained by the laws of nature, so no faster than light travel or time travel. We blast out of the solar system at a decent fraction of the speed of light, impossibly quick for our current technology, but likely something we can achieve in the future. This seems to be a repeat of our first rocket, and we will reach the same destinations but just at a much slower pace. But this rocket encounters the most surprising edge of them all. The universe is expanding at an ever-increasing rate. This means that if you pick two locations in space that aren't bound by gravity, there will be more and more space between them as time goes on. All galaxies, on average, are moving away from each other, and this process is ever increasing. The expansion today will be greater than the expansion yesterday. This is the effect of the mysterious dark energy, which amasses the vast majority of the energy in the universe. In our realistic spaceship, we can travel for an enormous time. We travel past many galaxies, but as time goes on, they take longer and longer to reach, as new space has appeared between them. We seem to be approaching these galaxies at a slower and slower velocity. Eventually, the galaxies ahead appear to be moving away from us at the speed we are travelling toward them. We can't approach any closer. As we are travelling in a realistic spaceship, we only had a limited amount of time to fire our engines, maybe a few weeks or months at best from the start. And then we coast along, having used up all our fuel. These distant galaxies are unreachable because we can't accelerate anymore. You may think we can cheat this by having our spaceship be incredibly powerful, perhaps travelling at close to the speed of light relative to Earth. After all, we believe nothing can move faster than the speed of light, right? But this is not quite true. Nothing can move through space faster than light. Space itself can expand faster than light. So even if we travel at the fastest speed possible, we can never reach most of the universe. Most of the universe is travelling away from us faster than light. Clumps of nearby galaxies have enough gravitational pull to overcome this expansive force. Our local group of galaxies will collapse into a giant mega-galaxy in billions of years' time. These clumps of galaxies will, in time, become isolated from the rest of the unreachable universe. In fact, in billions of years' time, people will look out onto what seems like a much smaller universe. The edge of the universe in this sense is one of being isolated, travelling further and further, but the universe ceaselessly flowing away from you, faster than it's possible to travel. The whole universe is large, but we are cut off from it. When we give up chasing these galaxies and try to find home, it's again impossible to reach. The expanding universe has carried our galaxy, the Milky Way, to an unreachable point, beyond a cosmological horizon. To me, this is the most profound edge of the universe, one that isn't defined by a barrier, but an expansive force intrinsic to our universe. These are the edges of the universe. Thanks for watching.